I'd like to reintroduce to those of you who've not yet had the pleasure of meeting Fernando. Fernando España, he is the president of ConstructX. He's been helping us lead these AWP and Lean webinars. Today's another step in the collaboration of the AWP and Lean concept. And with that, I'll go ahead and hand it over to Fernando, and he'll introduce our presenters today. Thank you.
All right. Thank you, Jenny. Yeah, so welcome to this series of webinars that we're presenting on the AWP plus Lean Joint Working Group. So we'll tell you a little bit about us. So we started this in 2021, and myself and John Strickland with Collaborative Flow LLC are the co-chairs of it. And you can see we have a lot of members from the different institutes, besides CII, LCI, PPI are all members, a lot of owner groups, EPCs, universities, as well as other consultants and technology groups. So we've got a really strong following and interest in this AWP plus Lean. So if there's any interest, you can reach out to myself or John Strickland at those email addresses below, and you'll get a copy of these slides. Why don't you go to the next one? So yes, I mentioned we formed in 2021 through a big interest of looking at how we bring both AWP and Lean together. That's how it started, but our vision was to raise this awareness between AWP, Lean, operations science, other best practices, and really successfully leverage it in all the project delivery formats that we can across all the different industries and really drive that adoption. So we actually established this open working forum where owners, service providers, academia, anybody can really join. So it's not limited to CII members, which has made it really great. That way we can explore these blend of approaches. So why don't you go to the next slide? So just to let you know that this is one of a series, and today is of course all about modularization, offsite build, and DfMA. Next month, we're going to be exploring target value delivery and its applications. Big rooms, interactive planning, AWP plus Lean was a popular topic. That's in September. And then at the end of September, there's a lot of other conferences happening. We're going to talk about site materials management. And then in later October, contracting strategy and requirements, and then look ahead planning from a production control perspective here in November. All subject to change, but we do have an exciting lineup for the rest of the year. So with that, I'd like to get on to what you all want. So I'd like to introduce the panelists for today's webinar. First, David Kerr, Shell's Modularization Center of Excellence. He really drives maintaining the modularization body of knowledge and supporting projects at Shell, predominantly pre-FID, with modularization assessments, concept selection, strategy development, and modularization definition and execution planning. He has really 21 years of experience in project delivery, predominantly focused on modularization and construction planning execution for the industrial projects in energy and chemicals. Also, Cathy Farina is with us. She's the Vice President of DyCat Solution. That's a company that provides innovative solutions in the heavy industry business sector. She facilitates a lot of workshops, alignment sessions with customers using DyCat's 4 innovative solutions: modularization, facility standardization, lean design, and execution. And she has 25 years of experience in the oil and gas, petrochemical, mining industries. And most recently, she has worked with global customers, providing the expertise, training, and tools to implement modularization, lean design, and standardization of all of their projects. And last but not least, got Peter Court, known him for a long time. Peter's the owner of TAKT Consultancy Limited, a lean construction advisory organization which specializes in improving mechanical and electrical on-site assembly processes and associated upstream activities on complex construction projects and within businesses. Peter's passion is to share and apply the knowledge he's gained and contribute to lean principles and methodologies to drive efficiencies in cost, labor, and productivity, and to improve on health and safety performance. He's definitely an advocate for transforming the way that we construct. So with that, I am going to hand it over to David Kerr, who will take us from here.
Thank you, Fernando. Yeah, so then just to quickly run through our agenda, we've done the introductions. Cathy is going to take us through a whistle-stop tour of modularization strategy. I'm going to attempt to cover modularization and AWP and how these two strategies come together. And Peter is going to finish us off with lean ways of working. Hopefully we'll get through that in some good time and leave plenty of time for question and answer before we have to close the webinar. So with that, I'll hand over to Cathy.
Okay, thank you, David. Okay, so I'm going to be talking today about the modularization strategy. But before we dive into the modularization strategy, I wanted to just go through some key definitions and terminology that we developed on actually RT 396, which is the CII research, it's business case alignment or analysis research for modularization that we are finalizing. Actually, we're going to be finalizing that this month. But some of those, I just want to get everyone aligned with some of those key definitions and terminologies before we dive into some of the strategy. So modularization, what is it? So modularization is that overarching strategy to move work off-site. So it is, what we want to do is we want to move some of that site construction labor, site construction labor off-site into a more controlled environment. And this is really to help improve project performance. So that's the key, our key definition for modularization is that strategy. Just next slide, David. So with that, we talk a lot about the off-site construction component to that strategy, to that modularization strategy. And in that, we have three different terminologies, key terms that we use. And it will, from the left to the right, it's going to be increasing in complexity and size. So we start with that prefabrication component, and it's really combining material together to actually create a greater component, like piping spools. So flanges, elbows, pipe together to develop a overall component. Same with structural steel. It's a structural steel frame. So some of the primary and secondary structural steel, combining those together to create the actual structural frame. And then equipment, of course, you've got your equipment that you can have prefabricated. The example here is a vessel, which you can actually have completely prefabricated and then transported to site to be installed. The next one is pre-assembly. And really what pre-assembly is actually combining some of those prefabricated components together to create a larger kind of subsection. And some examples of that is a pre-assembled structure. So you can see like a stair tower, a multi-discipline structure, which maybe is a stair tower. You can add like electrical and instrumentation on that. And then dressed vessels or dressed equipment, where you actually add the auxiliaries onto those pieces of equipment and then transport them to site, to the final installation location. And our last, more complex, is the module assembly. And that's really looking at combining the prefabricated components and the pre-assembled subsections together, all within a structural frame. And so some of those examples are pre-assembled racks or PARs or pipe racks, pre-assembled units or PAUs, equipment modules, vendor package units, BPUs, or pre-assembled buildings. Okay, next slide. So that, we want to also talk about the design for manufacturing assembly. So that was talking a lot about modularization and offsite construction, but we've also heard the term design for manufacturing assembly, or DfMA. And what this really focuses on is that manufacturing and assembly aspects for a product. So it's really looking at that design for manufacturing and the design for assembly and kind of combining those two together to improve that kind of quality and improve obviously the cost. I've got an example here. It's really looking at the before picture is a really complex mechano set, lots of components, lots of parts. Assembly is a lot more complex. And then when it went through the DfMA process, it went to a more simpler assembly, more simpler manufactured product. So this is just a key example of what a DfMA process could achieve within a product. Now for say a modularization project where we're talking about offsite construction, what we really want to focus on is for the design aspect is really designing for that fabrication and assembly. And that could be designing, say, your structural steel, bolted versus welded. It's really looking at those fabrication the processes they use, and adapting them to your design. And the same thing for the assembly portion of it. So assembling your module together or assembling your pre-assemblies together is looking at what are those assembly processes and implementing and designing them into your overall product, your overall module, your overall pre-assembly. And that could be, for modules, it could be pancake assembly or block assembly, depending on what they use. And then designing for transportation, that's another one that you really need to look at, and that's looking at the design factors, whether it's going over just land or going over land and water, and what are those factors or accelerations that you need to incorporate into your design. So looking at that early, and what are those factors that you should be implementing and including into your design. And then design for installation. So looking at your modules or even your pre-assemblies as they're coming in, and how are they being set, if they're modules, how are they being set onto the foundations, and making sure that your design can accommodate it. So are they being lifted on or are they being rolled on? And making sure that if you have, they're lifted on, the lifting lugs are designed appropriately to be lifted on, or they're being rolled on, you've got the self-propelled modular transporters or SBMTs, you've got allowance for them. Okay, next slide. So just looking at this graph, this is kind of coming from the research, our T396, that we're currently just finalizing. And I'm not going to go through all the activities, but this is a decision to modularize. It's basically looking at a curve where, you know, making that decision earlier, you're going to gain the most benefits out of modularization. And it's because there's some key activities and early information requirements that you need to do, that you need to perform earlier for a modular project. So I'm not going to go through each one of these numbers, but I'm going to just highlight some of the numbers going through. So when you're looking at a decision to modularize, the earlier you can get in, the earlier you can get some decisions and assumptions around some of those key factors like site location or infrastructure requirements. That would be ideal, because you may actually be able to choose the site locations that optimizes your modularization a little bit more than another site location. So really looking at those different factors earlier on, you can maximize those benefits that you'll get from modularization. And also you need to start to look at some earlier factors like your transportation logistics. So kind of where are you going to get the modules fabricated and assembled, or your pre-assemblies of fabricated assembles, and then transportation logistics around them. Some of your site characteristics are going to be important. I talked about site location, but infrastructure, the road systems by water, some of those key factors are going to be really key on being able to really develop a really optimized modularization strategy. And it also feeds into your module concept. And so you really want to get that module concept, which is your module envelope limitations. So what's your maximum module envelope and weight that you can transport and that you can actually install at site. And that's going to feed into then looking at your plot plan and creating a modular plot plan earlier on, so kind of in that FEL 1, FEL 2 phase. Because you want your concept finalized in number 3. So number 3 is going to be your module concept finalization, which is in that FEL 1 assessment phase. And then you're going to be really developing that plot plan and looking at your overall layout and how you'll modularize that layout. And then just another key component is you really need to have that strategy really locked in at the end of the FEL 2 selection phase. And then your basic design is really doing your design development for those modules based on your module concept, on your module strategy. And you're going to have some of your execution and your design decisions being locked in or frozen. And by the end of the basic design, FEL 3, you really want that design frozen to be able to actually now execute in the EPC phase or in the detailed engineering phase. If you don't, you don't want any recycle in that EPC phase. You don't want to have change, and you don't want to have design recycle. So that's what we're trying to prevent with that design freeze. Okay, next slide. And then I just wanted to highlight that earlier development of your module concept and your modular key plot plan. It's really the importance of also looking at your early path of construction. So in that kind of DBM phase, your early DBM phase, your early path of construction and module sequence is going to be key, because it's going to really set your schedule. It's going to set your planning, your priorities for your engineering and supply chain in the feed FEL3 phase, and of course in the detailed engineering phase. So just those commissioning priorities are really, and startup priorities are really going to feed into what your path of construction, your module sequencing. Then that will actually feed into your work packages, whether they're module work packages or construction work packages. That will feed into your engineering work packages and your supply chain, and then go into your engineering deliverables, your delivery times, and when you're going to actually deliver your engineering deliverables and materials. So this is all very key. And when you're doing the path of construction and module sequencing, engineering and supply chain need to be involved because they may have some constraints that may prevent or need to change that path of construction or module sequencing. Okay, next slide. And this is just an example of more of a module sequencing for a very large or very highly modularized unit. And one key thing I wanted to just point out is with modules, you need to look at the full route of that module coming in from the site all the way to the unit, and then how it's actually going to be installed. So how you're actually going, if you're going to roll it in, how are you going to roll it in, and making sure that you don't have any interferences with cranes, with foundations, with current work that's going on at the site, and any other components that may be happening around that time that module arrives. And this gets missed often a lot, so it's a very important aspect to really look at both the path construction and module sequencing when you're doing that workshop. And then again, it should be done earlier on, and then you're going to be validating it throughout that project lifecycle. Okay, next slide. And then I just want to talk a little bit about the critical success factors for modularization. I'm going to probably go really fast on this one, but this was actually from RT 283 within CII. But these are some of these key factors that are going to set you up for success with modularization. And I did talk about a little bit of them already. So the module envelope and limitations and that preliminary module definition, those are key success factors to be done earlier on, and making sure that you actually understand and kind of lock those in to what they are going to, what you can transport and actually put onto your site. You need to make sure that you have that alignment on the actual modularization driver. So why are you doing modularization? Why are you implementing modularization on the project? And that alignment on that concept as well earlier on, but throughout the whole project lifecycle, because you'll get new people coming on the project all the time. And then your owner's planning, resources, and processes. This also includes the EPCs, making sure you have modularization, the resources with that modularization expertise and experience, as well as those processes. Very key, because it gives everyone alignment and direction on how they're going to perform the modularization. Oops, sorry. And then the timely design freeze. I talked about that in that previous slide. Extremely important to have that design freeze at the end of the basic engineering, and really only changes that are mandatory would be implemented in the detailed engineering phase. So just really focusing on how that would work and that process on making sure that you can manage that. And then that owner furnished long lead equipment, making sure that you understand that what is long lead, because now you're going to have more long leads because they're going to go on modules, and planning for that up front, making sure you have budget set aside for that up front, and it's part of your overall schedule. And contractor experience is the last one there that I want to talk about, but that's a little bit same thing with the planning, resources, and processes. The EPC contractor experience you need to have, make sure that they have that modularization experience, and also the process and guidelines on their projects as well. So just a note, if you are interested to learn a little bit more about modularization, please come and join us, the Modularization CBA. You can email myself to get the invite onto that Modularization CBA, which is the Communities for Business Advancement. And also we're going to be, our RT 396 resources and tools is going to be issued out in early fall, so look out for that. I'm going to pass it over to David now to talk a little bit about modularization and AWP.
Thank you very much, Cathy. Okay, I'm moving on then to modularization and AWP. So a very quick tour through the emerging view around this topic. So when we think about our overall advanced work packaging strategy, we typically think about traditional stick build execution and how we can invest more effort before construction in order to deliver for construction and therefore give the site the best chance for improvement and for success. But what we're increasingly seeing is that stick build isn't the default strategy. When we take into account the full range of modularization through the componentized prefabrication to pre-assembly to the modules themselves, almost every project has some sort of element of offsite build or modularization. So when we switch to that strategy, we see that the picture changes. We've introduced two new execution stages: fabrication and assembly, transportation and logistics associated with moving those modularized elements to the construction site. We've increased the number and complexity of overall work processes and execution workflows in our effort to reduce the complexity and number of work hours at the construction site, which is comparatively less productive or more expensive, and take those hours away from the work front. So as you can see, modularization and AWP have the shared aim of improving overall project performance, in particular at the construction site. But in doing so, we must recognise how our overall AWP programme must also be modified. So in the next few slides, we'll quickly run through some of the key differences and objectives in each of the project phases that we need to think about for the AWP programme in order to enhance the overall modularized execution strategy. In developing the modularized concept, we need to assess both the level and maturity of our organisations that will be involved in the given project locations and the expected contracting strategies. So that's owner teams, main contractor teams, fabricators, others in the supply chain, site contractors, and how AWP may be deployed for both the modularized and the remaining site constructed scope. This expands our use of the available tools and technologies between more organisations and impacts the options available and the requirements that need to be set. Execution, as we've seen with Cathy, for a whole set of new reasons with AWP, must be planned from the earliest possible moment, and therefore that same early definition is required. Here, module and construction work area definition overlaps, and as Cathy mentioned, so does the path of construction and the module installation sequence. Module and AWP coding structures crucial for packaging the scope. That has to be seamless, and the identified data that's generated has to be able to be managed by the tools and technology available with the executing parties. We have to recognise that the front-end design is the foundation on which detailed engineering and downstream stages is built on, and then we have to plan at the conceptual stage, set the requirements of the front-end design. With these factors in mind, it's always important to identify ambitious but ultimately achievable goals in which to manage your performance at the following project stages against. In front-end design, we define the construction work packages and the execution sequence. For modularized execution, they must now be adapted to include the module, hookup, and stick build scope. And the construction work packages need to reflect both the fabrication sequence and the site construction sequence. Easy to say, but in reality, this adds a massive layer of complexity to the planning effort. Our focus on productivity and performance improvement through design and front-end planning needs to take an integrated view of the fabrication and assembly locations as well as the construction site, and I recognise the scope and the way the scope is packaged and the handover between those fabrication locations and the construction site through transportation and logistics. Another key point here amongst many is to ensure that engineering and procurement plan to deliver for both the fabrication and the construction locations, and importantly recognise the differences in the deliverable content and timing for these different locations to suit either the fabrication sequence or the site construction sequence. Moving along the diagram then to engineering and procurement, we've already established that both fabrication and construction are the customers here. Now the crucial point is where we must ensure that engineering and procurement execute the AWP plan, this more complex AWP plan. This is the first point beyond, getting things defined properly, where the modularization strategy can fail due to the knock-on effects of getting this part wrong. We need to ensure that the right deliverables, and that's right in all senses of the word, completeness, quality, integrity, at the right time. Using that, we can create and manage flow that successfully supports the downstream fabrication and site construction. Can we manage the newly created and actioned process of data creation and the digital interfaces between organizations at this most complex point? Can we, in short, through fabrication and construction, influence project management and project engineering to incentivize or reward and manage engineering and procurement performance against AWP delivery rather just than pure deliverable progress? Moving on then to deploying AWP at the fabrication and assembly location and the definition of IWPs within fabricators' construction management systems. Experience tells us that AWP done right will enable fabrication to undertake production planning in that more factory-like environment, to match resources to scope in a timely fashion, and ultimately enhance our fabrication performance if CWPs from engineering and procurement can be released as per the expected plan. In turn, fabrication through transportation logistics has to recognise that site construction is the next customer and have to be completely completions focused, such that modules as part of site construction CWPs are delivered predictably per plan with no surprises, ready for site installation. Another key point here, often forgotten, at least until it's too late that is the scope that lies between module mechanical completion and pre-commissioning at the fabrication location and the eventual site installation. That is in the packaging, the preservation, the loadout, transportation, the offloading, the reinstatement, which in itself is a project, all of which has to be packaged and managed as part of the AWP program. So lastly, we move on to the site. So I went a bit too fast there. Lastly, move on to the site, where infrastructure and civil CWPs must be delivered to support the module installation sequence. And with a fully informed and in a timely fashion, a construction team can ultimately manage IWP execution of the site scope, and ultimately, having going through all these steps, realize the intended original improvement required in project performance at the construction site. So to summarize then, AWP and modularization are complementary, working together to improve the overall site construction performance. We have opportunity to think about the work processes and workflows which support packaged downstream delivery of scope between these steps. In doing so, we have an additional opportunity to introduce lean ways of working to these work processes and workflows. And with that, I'd like to hand you over to Pete, who's going to take us through some of those lean ways of working.
Thank you, David. Excuse me. So as you see on these slides, I will discuss delivery of engineering, procurement, fabrication and assembly, transportation and logistics, and site installation in relation to design for manufacturing assembly, pre-assembly using product family concept as part of a workflow system, TAKT planning in construction, ergonomics, demand fulfillment and postponement, and overarching production systems in construction. And because there is a lot to cover in the time available, I've produced a list of reference research at the end of the slides that can be used to explore for further knowledge and understanding and how lean themes relate to what's discussed today. And also those papers themselves, excuse me, refer to extensive further research that underpin the discussion today, and primarily in the International Group for Lean Construction agenda. So aims and objectives. The overarching aim is to transform traditional construction processes into one based on technological innovation, and in essence transforming traditional construction into a modern process of assembly. And that's using DfMA, that's been discussed, within an integrated digital delivery strategy, engineering within the model environment, on-site assembly of modules and kits of parts to form complete systems. I predominantly focus on MEP. Within ergonomic workplace designed work cells in a synchronized production system, with the aim of resulting in fewer on-site operatives carrying out safer and more productive and simpler assembly tasks for a shorter period of time. And the production system talked about today has been implemented on both industrial and commercial construction projects, so they are applicable. Okay, so talking about design, delivery of engineering procurement, and Cathy's touched upon this, as has David. The most benefit is gained from early involvement. But just to talk about this DfMA design funnel, as I've called it, you will see the two colours, the red and the green, or the outer and the inner. And the inner funnel benefits from strategic and technical solutions early. In other words, there's less scope for iterative design. So through those generic design stages of concept, develop design, technical and construction design stage, you go through this process of iterative design, increasing definition, integration and detailing for manufacture. And to make this a success, the inputs to that are customer requirements, the core values of the particular project, overarching aims and objectives, DfMA guiding principles, design parameters and ground rules, all of which can be developed with a common understanding within the team. Designing around product families and pre-selected products, DfMA design guidance itself, and other manufacturing techniques such as ABC parts analysis, early equipment selection, and really understanding DfMA benefits criteria. In commercial construction, DfMA can be viewed to add a cost and add time, so you really have to understand what the benefits are to convince the stakeholders that it is in fact the right thing to do and not just something to do at that stage. So yes, there's plenty on that slide, so I won't discuss it all, but we can move on to the next slide. So I talked about product family. So here's a generic commercial construction MEP product family, and this is equally applicable to to other components in the building process, such as substructure, building envelope, internal building fabric fit out, and conveyancing systems and that sort of thing. So if you take MEP, you've got the larger end of the system, which is plant rooms. So that gives you volumetric plant rooms, plant equipment modules that fit inside pre-constructed plant rooms, vertical distribution, risers, horizontal distribution, terminal distribution modules, fan coils, VAVs, etc., electrical modular systems, whole volumetric spaces, and the balance of kit of parts, which is everything else that interconnects modules and connects modules to other devices in the facility. Okay, next one. So delivery of fabrication and assembly. So DfMA is more than just pre-assembly or off-site manufacture. There are thousands, if not millions, of parts to be managed in construction processes. So in construction, the supply chain can be categorized using ABC parts classification from manufacturing. You will see that modules will be category A, where there are lower quantity, but they are higher value and they're generally made to order. Components category B are medium quantity, medium value, and these can be made to order and made to stock. So in MEP terms, a made to order item could be a pipe spool, and you'll see some in the pictures there. And a made to stock item could just be straight pipe or standard supports that are bought off the shelf. And then consumables are the hundreds and thousands of nuts and bolts, etc., that are high quantity and low value, but generally made to stock. So in manufacturing systems, assembly strategies are essentially just in time, and a production system that culminates with just in time is very efficient if everything works and runs perfectly, but it's fragile if there's any problems. In a lean system, therefore, all resources used in the production process must be foreseeable and reliable. So here you can use safety lead time to protect MTO products, which is a time buffer, and safety stock can be used for made to stock products. They're low value inventory products, so it's okay to keep stocks of those as they're low value. So this helps protect the system, the production system, against uncertainties in production and demand timing. Next slide, please. So transportation and logistics. So at the bottom, we've got the on-site construction assembly process, and that has to be fed by the categories of materials discussed. So type A, parts made to order, type B, parts made to order, and then type B, parts made to stock, and type C, parts made to stock. And those need to be protected with safety lead time, as you'll see on the left, for made to order items, and safety stock for made to stock items. And you can see the red demand signal from the construction processes and the black demand fulfillment signal. Now, if you want a just-in-time process, then postponement function can be used, which in essence means delaying delivery of the particular part until the moment it's needed. So you don't have the workers looking around site for various parts or waiting for things. They have to be available. So that is achieved, as I've said, with safety lead time for manufactured items and safety stock. So materials are always available. And this can give rise to the use of demand fulfillment centres. And one of the best examples in the UK of that was used in the London Olympics in 2012, which managed all the material flows into the various developments that form the Olympics. Next slide. So delivery of site installation. So AWP path of construction can be seen on the right-hand side. So this is divided into construction zones, or assembly zones, as I've called them there, and assembly weeks. So here I've used a week as an example. So the work is balanced, so every team has the same amount of time to undertake their assembly activities. So zone 1 in week 1 is team 1. That team moves into the next construction zone in week 2, and so on. And then team 2 comes in behind them, all of which are fed with either modules or kits of parts direct to point of use when they're needed. So you can see that postponement function that's holding those kits of parts and even modules, subject to the size of the modules. So they are called off with the demand signals and delivered just in time to the point of use, exactly when they're needed. And that is supported by purpose-designed mobile work cells that are ergonomically designed to ensure that the work is designed to fit the worker and not the other way around. So as much as possible, all the work is designed to fit within the physical range of the operative. And that means that as a natural byproduct of that, productivity goes up for the individual and their health and safety well-being goes up as well. So that's a particular activity to design specific mobile work cells dependent on the function. And that's everything for the person, for the parts, for the tools, for their accessibility to the point of use, all to keep that work within their physical range. Just seeing how I'm doing for time. That's okay, next slide. So the overarching expected outcomes is to satisfy the customer needs and requirements, which is a key lean theme. Look after our people, as everybody has a right to go home safely after a productive day's work. To challenge and change the general poor image of construction. If you visualize a poor construction site, you can exactly see what I mean there. There's increasing time, cost and resource constraints on projects. To bring a high degree of certainty to project delivery in terms of safety, quality, cost and time. and from an MEP perspective, to protect valuable commissioning periods, which is invariably squeezed at the end of the project when the installation phase overruns in time. And lastly, last slide is just the list of reference papers. By all means, if you can't access those, drop us a line and I can get them for you, and that's it.
All right. Thanks to all the panelists today, and we'll be able to take a lot of Q&A. So if you have anything, make sure you put them in the chat window. We do have a couple here. One is about sharing the slides, and also this being recorded. So I think the intent is that they will be distributed. You'll get something from CII directly, and I believe Jenny, that might be what, maybe a week or so.
That is correct, yes.
Yeah, so you can be looking out for your email, and you should be able to get a copy of the slides that you're seeing. Thanks to David, Cathy, and Peter, and you'll also be able to get a copy of this recording. So yeah, so let's we've got a couple questions. Let's go through. The first one I think was regarding Cathy's slides. And the three designs, which I think is the design for DfMA, design for transport, and design for installation. I believe the question here is, are they always required to develop it, or could it be possible to focus on the design of one of them?
Okay, so I was thinking that they were talking about pre-assembly, prefabrication, and modules, because if you're gonna, for the design for the DfMA, if you're talking about DfMA, design for transportation, design for fabrication and assembly, and design for installation, you will need to design whatever it is, your prefabrication, your pre-assembly, or your module, those kind of components in it. If you're talking about pre-assembly, the prefabrication and modules, you can actually focus on, say, stick-built projects right now really do focus on, they use prefabricated structural steel frames and most likely pipe and spools. So they already are using a form, I guess, of modularization, you can say. But to really maximize your benefit of modularization, you really should be looking at all three of them. You can just use, say, prefabrication and pre-assemblies, but you have to do a business case. And what we talk about in the business case analysis research is we got a tool that you actually go through and really analyze what makes sense for your project. Is it the prefabrication plus pre-assembly? Is it prefabrication, pre-assembly, and modules? And what size and type of modules you go through. So you could focus on one, but our recommendation is really to go in with all three strategies and really looking at what you can do to actually maximize the benefit. Hopefully that was what, versus, because design for fabrication, assembly, transportation, and installation, really you have to do that for all your modules.
All right, I don't know if anybody else wants to make a comment on that. If not, I will. I mean, if you miss one and say you didn't have a voice in the design for DfMA or pre-assembly, and you receive something, putting the effort to design the transportation, given what you've got, in an AWP and Lean fashion, you'll always drive benefits. Or even on the install process, that's what AWP and Lean is all about, right? And it's been around for a while. So you can always get benefits, but as Cathy is saying, and the rest, hey, the earlier you do it, the more benefits you will get. And Cathy had that great slide showing that influence curve. I see it as making early decisions, get more out of it.
Yeah, and you look at your strategies, absolutely, Fernando, up front. Even if you're later, I can answer the next question really quickly too. It's about concluding feed phase. If you wanted to do a modularization concept at the end of feed, you absolutely can. We're not saying you cannot do it. You just won't have the maximum benefits modularization brings. The earlier you come in, the more influence you'll have in your project around specific factors that may influence modularization, but you can definitely modularize after the feed phase. You can put a pre-assembly strategy, you can put a prefabrication strategy in. It just you'll have some time, you'll have some schedule that you'll need to build into that, maybe 3-4 months, depending on the complexity. But you can do it, it's just, you will have a little bit of a schedule delay to do it after the feed phase, if you're implementing modularization after the feed phase.
There you go. Okay, thank you. So another question is regarding AWP. This may be to David Kerr first, but how many CWAs is recommended to identify in a project, or which is the sizing recommended for each one? I'm guessing it's from a modular perspective, but there's also one for a project perspective, which I can address as well. So.
Yeah, I don't think there's a number. I think you're very much going to be led by your level of modularization. Do you actually have modules that are units, the large size modules, because that naturally fits as a construction work area in itself. I think beyond that, you need to look at your construction sequence and how that works. I would say there isn't a maximum number, but you want to have as few as you can to adequately describe the required construction sequence. I think that's the best way I can put it.
Mm. Yeah, that's great. And of course, from an ADP perspective, whether it's modular or not, your logical groupings from a plant facility, can vary, but it's very much separated from looking at a plot plan, and could involve hundreds of thousands of hours, but then they get separated, and that's multidiscipline area, and then will get separated into smaller and smaller work packages that get integrated later on. So let's move on to the next one. I think this is Peter. What does MTS mean? That was in your slide, I believe.
Components that are made to stock.
So made to stock.
Nuts and bolts, for instance, or straight pipe. Anything you can buy from a wholesaler.
Perfect. This may also be to the group, but I know, Peter, for you in particular, do we have? Do you have a case for wastewater treatment plant process?
I've got a case study for water treatment.
Yeah.
Not necessarily wastewater treatment, but at the end of the day, these facilities are a mixture of concrete, steel, piping systems, electrical systems, motor drives, pumps. So I could separately share the case study for a water treatment plant in a remote location for sure.
All right. Another question here is, do we have standards that drive DfMA? So I'll open it up to the group. Kathy,
I guess that depends on I think organizations themselves would have. It all depends, I guess, but I know from my experience there were particular standards in the organization I work for, yes.
If we're talking about CII guidance or CII standards, I think that really points to what we might be developing, Fernando, as part of this joint working group. So I think if that's something that the person that's asked the question, or anyone else wants to get involved with understanding, developing, then I would ask them to join the group and let's take it forward. I think we understand what the aim is, both from a lean perspective and from a modularization perspective. But I think this is the area that we're really working on in terms of what does that look like for us in the industrial projects.
Yeah. Perfect.
It would be good to have a glossary of terms as well between Lean and AWP.
Yeah.
I mean, Lean
yeah.
So because people call the same thing different things.
So here's a question. How do you organize a process of defining modularization strategy, imagining the organization is completely on stick-built level at this point?
Yeah. So what we are, I'm not gonna, that's a whole different webinar. I'm gonna just say that right now. It's a lot of information, but we are developing, for the concept wise, we're developing some tools that can help organizations earlier look at modularization strategy, what they need to look at, kind of the key considerations. It's gonna be part of RT 396, so it's gonna be part of that toolkit. So what I'd recommend is that, looking at that toolkit when it comes out in the early fall. It's going to have a report that has a lot of the definitions, but we also are going through a lot of the considerations and such.
Yeah, and I also would suggest that you get, an expert involved with that because it is a complex process, huge opportunity, and there is an investment to make. So I would also throw that out there.
Absolutely, Fernando. Yeah, you definitely need the expertise if you don't have any in-house, for sure.
Yeah. Which parties should be involved and how to manage them into these processes? Any thoughts on that? Modularization, DfMA, who should be involved? From stakeholders, I would think, stakeholder management.
And how to manage them. David, are we talking about like when we're talking about the process that kind of David went through with the AWP and modularization?
I'd say that in the very earliest phases, these things need to be owner-led. So whoever the owner of the asset is, or whoever owner's project team is, whether that's being contracted in or not, or a consultancy. I think then it becomes a shared responsibility between the main contractor, whether that's engineering, procurement, construction, or some other kind of mechanism, to then work through that modularized concept and front end stage together, bringing the strengths of what's the desired outcome for the asset and the key project drivers, alongside the practicalities of the execution and understanding the supply chain and the market in which the project exists.
Mm-hmm. Yeah.
Also,
yeah.
to add to,
go ahead, Peter. Yeah.
Oh, sorry, to add to that, David. So in commercial construction terms, let's say a hospital, you might want to group the distribution of services in a certain way, and even develop zones that systems are contained within, so the plant is a certain size to make modularization easier and more transportable. So therefore you want to be involved with the designers at that stage, so you don't get a design that you then have to redo to reconfigure systems for the sake of modularization. So I think all those key stakeholders need to be assessed, whether it's stakeholder mapping at a certain point in time to decide who those people are against a set of ground rules, for instance, and all the related trades. So for MEP, you don't want to build a module that gets in the way of the following trade, for instance. So you want to provide accessibility. You want it to be accessible for maintenance. So there's an FM input there as well. So there are key stakeholders that can be identified. But it's all the subject matter experts, isn't it, from each of those stakeholders that can best drive the solution.
All right, here's another question. I think this might go to David, but do you suggest the using of IWPs in a modular fab yard? And I think are the manufacturers experienced with AWP?
Well, I think it really comes down to the fabricator and what construction management systems they use. I think that in general, you'll find that they will create, although maybe perhaps not call them installation work packages, they will create packages of scope for their crews to work. So really then it's about organizing your CWPs by discipline. That is the fabricator's discipline, whatever that looks like for your particular fabricator, and then allowing them to further package that work for their crews. So you can call that an IWP or not, but it's one and the same thing. So yes, I wouldn't say that fabrication yards use AWP or use IWPs by name, but in the methodology, they inherently do the same job.
Yeah, I would say right now the experience as manufacturers are catching on to advanced work packaging. We're on a few where IWPs are being used at the mod fabricators. So yes, I think people are going to start taking more and more advantage of this planning and execution strategies.
And the real benefit to the yard, as I said, is the predictability, if you do it right, of the delivery of engineering and procurement to the yard, such that they can match it with their own procured scope and their resources, and really work in a predictable way, because that's what fabrication yards want. They want to ramp up, they want to produce, and they want to finish in their production window. It really is factory thinking. rather than just taking what comes, because that's and having unstable resource curves, because that's where they lose time and profit, and that's what they're trying to manage.
Yeah, no, absolutely. I think it's going to be huge, especially when you think of all the material flows that go into a mod yard and have to flow out, like you mentioned, with transportation and pre-assemblies on site. Another question: is it possible to use BIM in modularization? If yes, what level of BIM in this case? And I think everybody's had that experience. Anybody have any quick one? I think I'd have a shot, but BIM, what level?
Go ahead, Fernando.
Yeah, yeah, for sure. Yes, if you talk about building information, that's a modeling, that's a model, information model. And if you're going to do this, you're probably going to have to be down to a fabrication level of detail if you're going to get a material, any kind of material information out of it and connection details. But if that's the question, that's how I would see that. So another one, are there case studies available focusing on success using these methods, failure analysis, or specific improvements over stick-built projects, reduced budget, schedule, budget? So does anybody want to answer that one?
Oh yeah, I think we've got lots of case studies, probably both, Peter, like we both have them in the commercial and in the industrial side, that many to varying levels of modularization as well. That this would be something like, again, another full webinar to go through some of those case studies, but there is lots of projects out there that are huge success stories using modular methods, and there's also some that aren't, that we learned a lot of lessons on. So a lot of the training, or a lot of what is happening now with a lot of the research is a lot of lessons learned, right? So we're going through with a lot of those lessons learned. So there is lots of case studies available. Where are they available? I know there is, we've got some in the RT283 that we did research back in 2013 for the heavy industrial side. And of course, a lot of varying companies, like we also have a lot of case studies that we use in our training.
And I think another point to that is there a break-even point, between modular and stick-built?
There is, yeah. Yeah,
and that's another study, I'm sure.
Yeah. Hold on, yes, that's a whole topic that would probably, well, we only got 2 minutes left, so.
Yeah, absolutely.
The pure cost aspect, which you can demonstrate that modularization offsite build will work out cheaper, but then there's the execution risk around that. So you're looking to minimize execution risk at the site, but as you see, you introduce a whole load of new execution risks by adding to the complexity. So the key point is that you've got to manage where the risk is, put the appropriate mitigations and controls in place, and set the plan early and execute the plan, and leave it flexible enough that you can respond timely way to the things that don't quite go to plan, as they always do.
Absolutely, and understanding it, yeah.
All right.
Look at the activity count alone, David. The amount of activities assembling modules versus the activity count for assembling millions of parts is vast, isn't it? So there's undoubtedly benefits that modularization sort of is an insurance policy for delivery on time. You've just got to address the costs and the front-end design issues that you face, and early equipment selection, and all of the issues that brings.
Yeah, and also early, you have to actually plan for it. So you don't expect to take a stick built and just modularize it and expect it to save cost. And so absolutely, Peter.
Well, thank you all. I think there were a few questions we didn't get to answer, so if you all don't mind, I'll send those to the team and they'll respond to you directly via email. Cathy, David, Peter, Fernando, thank you all very much for your time today. We really appreciate your expertise on this topic, and we look forward to the next AWP Lean webinar coming up next month. Did we say that's going to be August 7th, Fernando?
Yeah, August 7th.
Lovely. We'll see you all then. Hope to see you at the CII conference. Have a safe week, everyone.
All right. Thank you very much. Bye, everybody.
Bye.
Bye.